Okay. Okay, sir.
Yes. Yes. So that simple pendulum performs linear ascension, hence derive expression for its time period. First, we'll see what is simple pendulum. A small metallic sphere called as bob, suspended with the help of light inextensible string of length L from rigid support at point O, is called as simple pendulum. OA is the equilibrium position. The pendulum is given small angular displacement theta and released. Then it performs oscillation on both sides of equilibrium position. Let x be the linear displacement. Is right till this? A simple pendulum consists of small metallic sphere called as pop, having mass m. A simple pendulum consists of small metallic sphere called as bob having mass m, suspended with the help of light in extensible string of length L from rigid support at point O. Let OA be the equilibrium position. Let OA be the equilibrium position. The pendulum this much part you have completed?
Yeah, sir.
The pendulum is given small angular displacement theta. Small angular displacement theta hit and released. The pendulum is given small angular displacement theta and released. It performs oscillations on both sides. It performs oscillations on both sides of equilibrium position. performs oscillation on both sides of equilibrium position. Let X be the linear displacement. The forces acting on the bob at displaced position B are its weight mg vertically downwards. Second, tension B along the string. Weight mg can be resolved into two rectangular components. A. Mg cos theta along the string. B. Mg sin theta perpendicular to the string. Mg sin theta perpendicular to the string. Is completed till end?
Yes, sir.
Mg sin theta perpendicular to string, Mg cos theta along the string. See, this string is inextensible. So this Mg cos theta cannot pull the string and tension cannot compress the string. That means both must be equal and opposite.
Yeah.
Only unbalanced will be this Mg sin theta, which is trying to bring the bob back to its original position. The force which brings the body back, can I say it is restoring force?
Yeah.
One more line. If this is circle, then what is this called as? Arc of circle.
Yes, sir.
This is radius. This is center. This is theta. Any relation between these two?
Arc equals to r
Arc
theta.
equals to radius into angle. Correct? So for me, this is arc, this is radius, and this is angle. Okay. So this concept I'm going to use in this. Length of arc is radius into angle. since the string is inextensible, hence tension balances empty cos. Thus, the unbalanced force is mg sine theta, which tries to bring the bob back to the original position. Hence, the storing force comma F equals to minus mg sine negative sign indicates that force is directed opposite to the displacement. Please copy to this. Computer,
No, sir, 1 minute. Done.
everybody is done? Again,
Yeah, sir. Yes, sir.
just wait, let me complete the start. Since theta is very small and measured in radians, therefore sine theta is approximately theta. F can be written as minus m, but by Newton's second law of motion, F equal to ma, where a is acceleration in the box we can say therefore MA equals to minus A equals to minus G. Since length of R equals to radius into angle. Length of R means X, radius is length of string into angle theta. So theta equal to X by L. A equals to minus G X upon L. Is G constant or variable?
Constant.
And length of string also constant. So that means here G and L are constant.
uh,
Just copy to this so that I will explain conclusion one line. Theta is very small and measured in radian. Therefore, sine theta is approximately theta.
Excuse me, sir.
Yeah,
सर यहाँ पे f equals to minus kx क्यों नहीं यूज किया?
स्प्रिंग नहीं है ना बेटा ये?
Okay. Yes, sir.
वो स्प्रिंग के लिए यूज करते हैं.
Yes, sir. Thank you. Sir.
Done, sir.
so we got A is minus G X upon L. Since G, comma L are constants, therefore A is equals to minus constant into x. So a is proportional to minus x. This is nothing but our definition of linear acceleration. This shows that simple pendulum performs linear acceleration. Hence, find time period. Since A is minus x upon L, A I can write gx upon L in magnitude. Therefore, A upon x is g by L. Time period capital is 2 pi by omega. Omega is root of a by x. I am explaining how. That is 2 pi root of g upon L. So I can say T is 2 pi root L by g. This is expression for time period of simple pendulum. Now, how this omega is root of a by x? See, we have proved a is omega square x in acceleration in magnitude. So a by x is omega square. So root of a by x I can write. Clear?
Yeah, sir.
Then now copy further. This entire derivation can be asked for 4 marks. Last time you will write this is expression for time period of simple pendulum. This is expression for time period of simple pendulum. Done?
Sir.
Last line. This is expression for time period of simple. Laws of simple pendulum. See, 2 pi constant, g constant. So what is relation between t and n?
Directly proportional to root L.
So time period t is directly proportional. Time period capital T is directly proportional to the square root of its length. Can I say this inversely proportional to square root of acceleration due to gravity?
Yeah.
Time period capital T is inversely proportional to the square root of acceleration due to gravity. Square root of acceleration. Can you see anywhere mass of the bob in the formula? In the formula, anywhere can you see mass of the bob? You have to just see an answer. Don't think much. Mass is present in the formula or not?
Yeah.
Huh?
No, sir.
No, no. So it's clearly visible. If we are having formula as 2 pi L and G, nowhere mass. So I can say it is independent of mass of the ball.
Okay.
Independent of mass of ball. Does it depends upon amplitude? That means if I displace it by 10 degree, 20 degree, 30 degree, does it depends upon that? No, no.
No.
So we can say it is independent of amplitude of oscillation. Independent of amplitude of oscillation. This independent of amplitude of oscillation is also called as law of synchronous. Law of synchronous. So we can say fourth point in note you will write is called as law of synchronous. Write this 4 point and note right down. Yes, done. Fourth point.
Yeah, sir.
Okay. Seconds pendulum. A simple pendulum whose time period is 2 seconds is called as seconds pendulum. A simple pendulum whose time period is 2 seconds is called as seconds pendulum. Derive expression for length of seconds pendulum. Derive expression for length of seconds pendulum. Time period of simple pendulum. Just now we derived, it is given by 2 pi root of L upon. For seconds pendulum, t equals to 2 seconds. Therefore, 2 is 2 pi root of L by G. So 1 equals to pi root of L by G. Squaring both sides, we get 1 equals to pi square L by G. Therefore, L equals to G upon pi square. This is expression for length of second square. Now write definition and derivation. Yes, completed.
Yes, sir.
Theory we have completed. I'm starting with numerical. Theory of oscillation. After the deduction of syllabus, we have completed.
Okay.
Because next part is angular SHM definition, that is deleted. Then the projection of UCM is SHM deleted. Damped oscillation is deleted from the syllabus. So we have completed as per the board. Now numericals we are doing from textbook. One second, okay? We'll just get the textbook so that numericals we get. From textbook, first question, which is multiple choice. First one. Question is like this: a particle performs linear SHM starting from mean position. Starting from mean position. Its amplitude is A and time period is T. At the instance when speed is half the maximum speed. Speed is half the maximum speed. Its displacement x is, first option is given root 3 by 2a, second option 2 by root 3a, third option a by 2, and fourth option is 1 upon 2. The same thing they can ask you even in numerical. Find the displacement where speed becomes half the maximum speed. Question if you have written, then I will clear and explain. A particle is performing SHM starting from mean, amplitude A, time period T, at the instant when speed is half the maximum. What is displacement? Can I clear this now?
Yes, sir.
Done, no?
Yeah.
Condition is speed is half the maximum speed. Since speed is half maximum speed formula, do you know it is omega root of a square minus x square? And maximum speed is what? A omega?
A omega.
Omega I can cancel. So when I square both sides, squaring both the sides, we get a square minus x square will be a square by 4. Half square is 1 by 4. Right?
Yeah.
So a square minus a square by 4 is x square. That means 3a square by 4 equal to x square. Root 3 by 2a equal to x is the required displacement. So option A. Solve properly. So all MCQs of textbook, do seriously, because they may give relevant to textbook the questions this year because of corona. Done.
Done, sir.
Second one, a body of mass 1 kg is performing linear ascension. Body of mass 1 kg is performing linear ascension. Its displacement x in centimeter in bracket they are given at t second is given by x equals to 6 sine 100t plus pi by 4. Maximum kinetic energy of the body is first option 36 joule, second option 9 joule, third option 27 joule, fourth option 18 joule. If displacement is 6 sine 100 t plus pi by 4, then maximum kinetic energy of the body is how much? This is the question. X is given in centimeter, you have to convert amplitude in centimeter to meter when it is required. This copy till this, then again I'm explaining now. Written?
Yeah, sir.
See, whenever you see equation given, here they have given equation x equal to 6 sine 100 t plus 5 by 4. Whenever equation given, always try to compare. So comparing with equation of SHM in general is a sine omega t plus pi by 4. We all know this plus delta, sorry, plus delta. Okay, we have derived the displacement is a
Yes.
sine omega t. So what is a by comparison? Is it 6 centimeter?
Yes, sir.
So can I say 6 into 10 raised to minus 2 meter?
Yes, sir.
And omega is 100, unit is radian per second, and delta is pi by 4 radian. Okay, by comparison I did this. They want maximum kinetic energy. What is maximum kinetic energy? Amen?
What, sir?
What do you mean by maximum kinetic energy?
Oh,
It is total energy is maximum,
yeah.
which is nothing but half m omega square a square or not.
Okay, yeah.
This is one method. You could have also taken displacement का derivative with respect to time, तो velocity आ जाता है.
Okay.
तो half m v maximum से भी कर सकते हैं, but एक concept याद रखो हमेशा. Equation given, always compare first time. Then we know maximum kinetic is total. Total का formula we know half m omega square a square. What is mass given? Tell me. 1 kg.
1 kg. Yeah.
Yes.
And omega how much we got? 100 na?
Yeah.
100. Yes.
And amplitude is 6 into 10 raised to minus 2.
Yes, sir.
2 3s are 6. So this will become 3 into 10 raised to 4 into
Sir,
10.
amplitude is square.
इधर है हाँ इसको स्क्वायर कर रहे हैं
हाँ
into 6 into 10 raised to minus 2 दो बार कर दिया 1 into same. So this becomes 18. 3 6 are 18 into 10 raised to this plus 4 minus 4. So can I say 18 joule?
yeah
Yes, everybody followed 18 joule answer.
yes sir.
Yeah, sir.
What logic you'll remember? Equation given, always compare. Then think what? K max is total, which is half m omega square a square. So it is everything we are playing with formula. If you can recollect formula at proper time, all problems you can solve. Copy. If you complete, please tell her.
Yes sir.
Everybody is done? Yes, Brunda completed?
Done, sir.
The length of seconds pendulum, the length of seconds pendulum on earth is nearly 1 meter. Its length on the surface of moon, its length on the surface of moon is dash. In bracket they are telling g on moon is 1 upon 6 times g on earth. Options are 1 by 6 meter, 6 meter, 1 by 36 meter, and d is 1 upon root 6. For seconds pendulum, length is g upon pi square. So can I say L1 upon L2 is G1 upon G2? Hello?
Yeah sir.
L1 is 1 meter, L2 we want, G1 is G and G2 is 1/6 of G.
1 kilo.
So L2 becomes 1 upon 6. This they have asked many number of times.
Yeah
See, nothing is difficult in physics. First time, yes, it is the toughest subject. But once you understand, then it is easier than maths, I can say.
Done, sir.
Just write one formula. When two springs are in series. When two springs are in series, then resultant spring constant is given by 1 upon k in series is 1 upon k1 plus 1 upon k2. like resistance in parallel, spring in series. This is how we can find net force or spring constant. Right,
Yes.
first formula. Same way for second one. When two springs are in parallel, then resultant spring constant, comma, Kp equals to K1 plus K. If you complete again, say one more formula I have to give.
Done, sir.
So suppose this is spring of force constant K connected to a block of mass M, then its time period is 2 pi root of M by K. Write this one.
Done, sir.
That's all for today. Tomorrow can we have class bit early?
Okay, sir. No problem.